Find the domain and range. We'll start with the domain. And the domain tells me which x's appear on the graph. And we can find them by drawing a vertical line through the x-axis. And then as we move that line around, we notice that none of these numbers hit the graph. So everything from -1 to 1, there's nothing there. And then over here at 4, everything to the right misses the graph. So the domain is broken up into two pieces. That piece and then this piece right here. So in this left piece, we have the domain x equals. What is the furthest left number on that graph? -infinity. So -infinity. What is the furthest to the right part of that graph? -1. Now we have to put the bounds on it. Can we capture -infinity? No, so it's going to be open, which is a parenthesis. Can we capture -1? Yes, because it's a dot, not an open circle. So for this piece on the right, we start at 1 and we end at 4. So from 1 to 4, is 1 included? Yes, so it's a bracket. Is 4 included? No, so it's an open. Anybody not understand the domain? We okay with that? Yes, open circle is an open parenthesis. Oh, okay. So the domain actually has two pieces. The range is going to have two pieces also. So we now look at these vertical lines and we see which one of the vertical lines hits the axis and which doesn't. So you'll notice everything down here misses, and then everything in this little gap misses. So we have two pieces, bottom piece and then a top piece. So in the bottom piece, what's the lowest number? -3 all the way up to 1, -1. So the range is y equals -3 to -1. Does -3 count? Yes, because it's an open circle. Does -1 count? No, because it's, or sorry, -3 is closed. -1 is open. Okay. In the upper piece, we start at 2, and we go all the way up to infinity. So this upper piece is 2, infinity. Do we include 2? Yep. So we have a bracket. Do we include infinity? Nope, we don't. Okay. No, just keep the warm-up with your notes. You don't need to turn that in. All right, how many of you do not have a graphing calculator? Look at number 1 on your assignment. We're going to graph these on our calculators, and then we'll draw the graphs by hand, and we'll answer the questions. So if I pull up my calculator, everybody push y equals, which is right here. Micah, you better take that test. Oh. Okay, so everybody push y equals, and then push or clear out whatever equations you have that are in there. And then you need to type in 4x minus 32. The x is right next to the green alpha button. So 4x minus 32. X is right here. Once you're done, push graph. If your graph looks different from mine, let me know, and I'll come over and help you fix it. So if you look at the paper, some of them say y equals, and some of them say f of x, like number 3 says f of x. This just means it's a function written in the variable x, and its name is f. It could be g of x or h of x or m of x, but any name of a function can be replaced with y. So we could replace the y on number 2 with h of x. Or in number 3, we could replace f of x with y. There is a mistake on the worksheet number 4. It shouldn't say 0. It should say equals y. Or the name of any function would work, actually. So I want you to draw that graph. And we want to find the x-intercepts and the y-intercepts. And the calculator will actually do the work for us. The x-intercepts are a little bit harder. Y-intercepts are super easy. Yeah, draw that graph. So it doesn't need to be perfect. Just get it close. The important thing is that you get the numbers right on the answer. So to find the y-intercept, we want to plug in x equals 0. So watch this carefully. Push second. Second. And then above the trace it says calc. And you have a whole list of calculations, and the first one says find a value. So hit enter on value. So second calc, and number 1 is value. Now you can just plug in whatever number you want. So if you wanted to know when x equals 2, it says y equals negative 24. 6, x equals negative 8. We want to know what is the value of y when x equals 0. So we plug in 0. Negative 32. So the first answer here is the y-intercept, or you could do y-int, equals negative 32. That's the first part of the answer. So on this graph, the line touches the y-axis at negative 32. Where does the graph cross the x-axis? We can try that. So let's plug in 8, and I get 0. Is that what I wanted? Yes. I wanted to know when does the y value equal 0. So I plug in 8, and I get 8 comma 0, so the answer is 8. The next one's a little bit harder. So the y-intercept is negative 32. The x-intercept is 8. If you want it wrong, go ahead. No, you don't have to. Yes. I'm tired of Robbie asking that question. If you want credit, do it the way I say. If you don't, you can do it however you want. Oh, Robbie. Okay, the next one, negative 6x plus 8. Push graph. So for the y-intercept, I just need to plug in 0. So second calc, go to value, and I want to plug in x equals 0, enter, and we get y equals 8. I just plugged in 0. The y-intercept is 8. You weren't listening when I said, or you could put y-int. No, that's too much to ask. All right. Well, what is the x-intercept? Well, let's try 1 point. Take a guess. 1 point. Well, you guys are too close. I want to make something further away. 1.5. So 1.5 gives me the answer negative 1. Is that what I'm looking for? No, what does it need to say? It needs to say 0. So we'll try 1.3. Well, I'm closer. Well, I'm tired of guessing. So watch this carefully. The calculator will give us the answer. Okay? Second calc again. Now, x-intercepts have 4 names. They're called x-intercepts, Sometimes they're called solutions, which we'll talk about later. Sometimes they're called roots, which we'll talk about later, but they're also called zeros. So we want to find the zero. So in this list, number 2 is 0. So we go to number 2. Now, it's going to ask us 3 questions, and this is a little bit tricky. The calculator is not smart enough to just find the answer for us. So it says, looking at what you think the answer is, tell me some number to the left and some number to the right, and then some number in the middle, and I'll tell you what the answer is. So we think it's really close to 1.3. So I need to pick some number to the left of that root. And any number to the left will work. Well, and let's not zoom in really far. We can make it a little bit more broad than that. So I could pick 0 or -1 or -2 or -3. It doesn't matter. I'll pick -2. Now notice, it put a little arrow pointing to the right. Now I need to pick a right bound. What's a number to the right of my 0? 3 would work. Now, you see how it has placed 2 arrows? Is my answer inside those 2 arrows? Yes, so I'm doing it right. Now it says guess. You don't have to be terribly accurate. I'm just going to put 1. And it gives me, the answer is 1.3 repeating. All right, let's graph the next one. X squared minus 4x plus 5. So going to y equals x squared minus 4x plus 5. If you look at these first 3 problems, the y-intercept is equal to the constant on each of the problems. So on number 1, the answer was -32. On number 2, the answer was 8. And this one is x squared minus 4x plus 5. And the answer is 5. The reason is, if you plug in 0, all of the x's are going to disappear. So if I plug in 0 on number 4, that x turns into a 0, this x turns into a 0, this x turns into a 0. What's my y-intercept? -50. Now, sometimes the equation will not actually tell you, like in number 6 or number 7 or number 8. It doesn't have a constant, so you're not sure what the y-intercept is. You need to use your calculator. Okay? So the y-intercept is pretty easy. What is the x-intercept? Where does this graph cross the x-axis? It doesn't. So there is no x-intercept on number 3. You better write no x-intercept. Yeah, of course. Yeah, I believe in abbreviations. Okay. All right, number 3. How do we do x to the 3rd? Right below the clear button is this thing called a caret. Don't know why it's called a caret. So x to the 3rd, what's the rest of the equation? Oh, look at mine. If you have the newer software and it looks like this, don't keep typing. You have to push over to get outside of the exponent. So you push 3 and then you push over. What's the rest of it? Help me out. Minus 25x minus 50. So let me look at your graph. Anybody else not get this graph? Looking at this graph, is it exactly on one of those numbers? Are the x-intercepts easy numbers or are they decimals? Well, you never really know unless you test it. So if you are really confident that it does hit -5, write -5. But if on a test it ends up being -4.95 and you write 5, you won't get full credit. So if you're unsure, you better test it to see if it is a whole number. So let's test this because there is a small trick to it. Let's focus in on this one, which appears to be -5. So second calc, I want to go to 0. What is a left bound for that root? -6. So I'll type in -6. Now here's where we want to be careful. When I pick my right bound, I want to make sure that I don't go so far to pass one of the other roots. So if I were to pick, say, -1, that's bad. Because from -6 to -1, there are actually 2 answers. So when I pick my right bound, I want to make sure that it only includes a single root. All right, so, oh, thanks. So what should I pick for my right bound? -4 would work, -3 would work. So I'll type in -4. For my guess, I'm going to do -5. And it turns out that this one was, in fact, -5. That's an x-intercept, yeah. Now, when we graph functions, you can have many x-intercepts, but you can only have one y-intercept. That's always true. You can only have one. Sometimes you have none, but you can only have up to one. All right, go ahead and work on the rest of this worksheet.